All right, let's get this party started. Party! Hey Ryan, hi folks. How's it going? All good. I forget where the chat is. Probably want to kill Discord here. Where is the chat? Okay, pop out chat. Dope. We have the chat there. Nope, I lost the chat. There we go. Can see y'all. How's it going, folks? Oh my god, so many followers already. Boy, swallow clone, shallow clone. Chris Rui Senpai, you can tell why I need types. I couldn't read that right once. Imagine typing it. How's it going, folks? Thank you. Thank you, Dylan, so much for choosing us for the raid. We really want to keep the OCaml train going. Les 24... how do you say that in French? Las 24 horas de OCaml. That's Spanish, though. Yeah, and sending you energies with all the stuff you're going through, man. Like, hope it will turn out well. So, what do we do now? Oh, right. Okay, I'll just close that so you don't see me seeing myself. Just leave this open here and catch you up with what we are up to. So, some of you may know I've been working on Runtime, our scheduler for OCaml called Riot, that lets you write OCaml programs like you would write them on Erlang or Elixir. So you have processes that you spin up, right? And they communicate via message passing that's typed, which is super nice. And in comparison to other schedulers for OCaml, right, that are essentially built so that we can support multi-core in OCaml, right? Riot is kind of, multi-core for free. It is not free, it's cheap, right? In the sense that you pay a small penalty in performance for some things. But once you write a program with Riot, it can run on one core or a couple hundreds of cores, and it will be fine. I haven't yet checked if it does run in hundreds of cores, right? But that's the premise, at least, right? In principle, the processes you spin up are very lightweight, so you can spin a dozen of them, or maybe a dozen thousand of them if you want, right? And the scheduler sort of takes care of making sure that everything runs here and there. For the most part, it's not a problem, right? And it works fine. Obviously, if you have like a wild true somewhere and you just like do a hot loop, then you're gonna like kill a core. But yeah, one of the problems this has is that all the schedulers are kind of incompatible with each other in some ways, right? And there's been some efforts to try to unify them, but that usually means you have like a sort of lowest common denominator that is not very good for anybody, right? So I've had to start rebuilding layers of the stack to be able to do things with Riot, like more higher level things. So we've been building a socket pool called Atacama that is doing very, very well. We did some, very unscientific benchmarks, and we were doing, comparable numbers to Erlang or Elixir. Obviously, we're maybe like 80%, 75% of the performance they get, but for a project that's just a couple of months old, I'm happy with that. I think obviously there's a lot of room for making the benchmark much, much better. And some people were talking about tripling the throughput of Go, right, with some improvements. I'm happy to see that happening here. So if you write Go or Rust or any of these languages really, and are thinking, look, this is bullshit, I can make my language go better, please, a PR is more than welcome. This is not a scientific benchmark. It's just a measure of how we're doing compared to other things you could run in your computer, right, with a lot of effort. We're also not doing a lot of very optimized work here. So if you look at the Go code here, this is just your run-of-the-mill standard library net server, right? And we just have a little loop here where we do copy in a buffer, and then we write into the connection from the same buffer. So there's not a lot of, hardcore going happening here. If you look at the Atacama version, it's pretty much the same, right? You sort of spin up a pool, say, okay, I want to be able to accept 100 connections at a time, right? And listen to this port, and this is the server, right? You just say, well, when I handle data, I will get data in a socket, and I will send that data back into that socket, right? That's it. That's the only thing you do. So for that kind of high-level interface, getting this kind of performance, I'm very happy with that. But you can't do much with a socket pool, so we are building support. If I have it open somewhere here. Okay, maybe I'll have to open it. We're building HTTP support so that you can actually run something that runs HTTP on top of Atacama, right? Like a server. And, oh yeah, we haven't pushed all of the stuff that we have here. But this is what we're up to right now, right? So this is the Nomad project. It's not that big. You have a little connection handler here, right? That this is an Atacama handler, so it's the same thing as the Echo server we saw, but instead of defining handle data and whatnot, we're just defining handle connection. And we negotiate the protocol, so we can look at the transport, right? And look at the wire and say like, okay, we have some HTTP2 data or not, right? Let's upgrade to HTTP2 or keep on HTTP1. And then we just sort of switch to a new handler, which means this is like all of the, right now this is all of the content negotiation, protocol negotiation we have, right? But from here you can go into the actual protocol. So depending on whether you return a module HTTP2, right, or HTTP1, we go there. And for HTTP1, this obviously starts getting a little more crowded, right? We have an Atacama handler, so it's kind of the same pattern, right? And here we have a handle data. So depending on how we do the parsing of the request as it comes, eventually we end up with an actual request, if I can find it somewhere here, handle data, right here. We end up with an HTTP request, and we just call run handler on that. So once we run our handler, if you're telling us to upgrade to WebSockets, then we can do yet another protocol switch, right? And this is where we are right now. Since we can build HTTP stuff just fine, right? Not very complex things just yet, but the basics are there. We wanted to do an upgrade to WebSockets to see if we could actually get that up and running. Secretly, I really, really want to do something like live view very, very soon. So I'm trying to get that vertical slice right up and running ASAP. But I'm running into some issues, right? The main one is that right now I have, actually let me show you how that works. So no, that's not what I wanted to do. Exact. Oh, right, wrong folder. So right now we're running the server there. If we run this little Node.js run script, right, it just connects via WebSocket. When the connection is open, it will do the thing, and then when we close, we log close and that sort of thing. It's just a pretty dumb thing to do. But once you open a connection, we set an interval, and every sort of twice a second, we send the test data. When you run that, we actually see that we switch from the protocol negotiation to HTTP1. We get some data here. The handler says to switch to WebSockets, so we switch to WebSockets. We have the entire connection here where you can see the connection upgrade, right, that we need for turning it into WebSocket. And the nice thing is that below, there's an error right now with message framing, but you see opened, which on the left we see only after the socket connection has been opened. So we do have WebSockets. The problem is that we're sending the wrong things in and out. Okay, so that said, the problem I'm having is that I'm trying to find the right abstraction, right, to let you specify connection handler, right, that can do a lot of things later. So I'm just putting a layer there, right, so that you can build routers, you can build your logger thingies and so on, right, but that also knows enough to be able to say, oh, I want to switch protocols, right, from HTTP to WebSockets and so on. And the reason for that is that right now there's this other repo called Trail, which is a very, very small version of something. If you've used Elixir, you've probably seen Plug. Where the hell is it? There you go. And Trail is essentially a clone, right, of Plug for this Riot OCaml stack, right, that lets you build pipelines of sort of connection handling, where you do a logger and you just put that there, and then you get logs for free, like at the beginning and the end of your request, that sort of thing, right? And this is fine, but it requires you to send a connection back, right? So between every step, you're sort of saying, okay, I'm gonna return a connection, so the next step can deal with that connection and so on. And now that I say it out loud, I'm thinking maybe this interface needs to be a little more, have a little more information. For example, whether you want to halt the connection, right? Maybe we just want to return halt, right, as a value, like an enum. Because right now, here in Nomad, right, when we go into that WebSocket test, we're saying, okay, we'll have a handler, and this is just a function from a connection and a request to some value, and the value is one of these two, right? Right, either we continue, and here's a connection, and then you can continue doing things and getting more data and so on, or we do an upgrade. So maybe that part of the interface should be in trail. So every time you define one of these trails, it's not a function from a connection to a connection, but rather a function from a connection to a halt or a switch, right? Or a continue even, right? So you just say like, okay, we want to just continue doing whatever we were doing before. So go on with the pipeline. I guess I need to do something like that. Why? Oh, sorry, off. There you go. Something like that. Yeah, so this is what I was playing around, trying to find a nice interface to do this. Yesterday and the day before that, we did the same thing with Atacama to be able to find the right interface for doing this switching, right, between handlers. And what we ended up with is just feels really nice, feels very comfortable and intuitive, right? Even if internally we're using recursive modules and GATs, right, to hide the fact that a handler has a different type than the current handler, right? Because if you go from HTTP to WebSocket, you would definitely want to have a different state. So maybe that's something else to point out here, right? Every one of these handlers, HTTP1, for example, this has a state which is not necessarily the same state as, I'm sorry, that's a lot of framing code here, as its other state, right? You may have similar things, and I think here we have mostly the same. But we have, for example, a different parser. We're just reusing HTTPF here, right? Here we implemented a parser from scratch, so we don't need that. And you want to be able to say, okay, this is the WebSockets module, right? It only deals with like correct WebSocket connections, and this is the state it cares about, right? So we can sort of think of that without having to also bring into sort of the table, right? Everything from HTTP1 and so on. So yeah, that's what we're doing here right now. Hopefully this sounds interesting to you. Ooh, I see the chat, a couple of messages. Oh my God, is the screen dead? Fuck. How about now? Oh God, what could have been worse. It was just a few minutes of yeah. Damn. Just OBS things, yeah. I don't know why it would do that. Yeah, so we're, as Sally the Goose, we're making a WebSockets library. Okay. So, long story short, we're making a WebSockets library. So that's what we're up to right now. I tend to keep this thing here. So we'll post more WebSockets in OCaml happening now. Cool. So with that said, let's see if we can find the right abstraction. Like in my head, as I was just saying things, at the very least, well-typed which, even without seeing the screen, was able to be like, oh yeah, I understand what he's talking about. But I don't know. Maybe this will make more sense as we go along. We were also listening to Van Halen, which I understand is not exactly what same kind of music we were listening before. So we'll do Ren, and we'll maybe do a fade into other things later. Ren is so cool though. Okay. So problem 1, right? How do we get the connection to be able to tell us what to move forward to? Because I think the upgrade has a problem. Right now, upgrade is just a variant here, right? Like a polyvar. And if we go into HTTP1, if we do handle the upgrade there, then at this point we have a lot of the request information to be able to create a handler for WebSocket, right? But we don't really have WebSocket upgrade options, right? Which you may want to pass. And I think more importantly, we don't really know what module you're going to use to handle the socket, right? The only thing we know is, okay, this handler, right, is done. What I would like to be able to do is say, okay, we're going to upgrade to WebSockets, right? And then we can maybe say like upgrade ops, right? And then pass in a module, right? And this module will be a trail. I need to figure out how to do that, if that's going to be the name or whatever. But we want this module to be a trail sort of piece, right? And so that means it will implement some type options, right, that we're going to be using, or arguments, I think I called it, and just create a state for itself, right? Right now we can just do that. So we can instantiate that module, right, to handle the connection after we do the upgrade. So in here we'll just do call, and I think it will make sense to do call, but maybe we will do something like handle frame. So every frame that we get, right, from the front end, that will be here, and we will have a state. And then we can do things here, like continue the connection, probably want to do frame connection state. Continue the connection, or maybe close the connection, stuff like that, right? I think that'll be fine. So module echo server. And then we want to pass the arguments, the initial arguments, right? So it would be something like this. We might want to find a nice function, right, or make this more ergonomic, but this is the basic data that we need to be able to handle the upgrade, right? Spin up the process that will handle the actual socket and run that code in that process. Thanks for the follow. I don't know who followed yet. Oh, this is such a good song. Thanks for the follow. No, Bush. Oh my God! Like I would not have expected that. That makes zero sense, right? Like I have trouble following some of it, right, while having the code in front of me. So it would be unfair for me to expect you to do otherwise. Thanks for the follow, Lazo. Azo. Yeah, so I think this interface makes some sense, but I want to understand if there's a constraint between the module interface and the WebSocket constructor here, right? Because right now, trail is essentially saying, all right, a trail is just a module that we know how to initialize with some arguments, right? And it will have a state internally that we can pass around on every call. I think we can do that. But I don't want to add a handle frame, right? If you're not going to get a frame. So maybe we want a separate interface for this right now. So you get frame T, right? But you don't need to return a connection. So this is starting to look like an Atacama handler again. Atacama handler, right? This is the interface. The main difference here is that the Atacama handler works at the socket level, right? So TCP, which means we just have a buffer data. We have no idea what it is, right? Up to you to figure that out. And here, you kind of want to restrict that to a frame, right? But we want to have something like this where we say, all right, I want to return, right, from this connection. I want to close the socket. I want to send the message, right? Or whatever else. So we might have a similar type like this. We'll see how ergonomic this is, but maybe we don't need to return a connection. If the connection is always going to be passed to us and handled for us, right? And the connection is not changing, maybe that'll be fine. What I kind of want to be able to do is just say push, right? And just give you a frame list. So the framework can figure out how to schedule those, right? For writing. Another small issue here is that right now the frame is something that we've defined here, right? With the parser and everything. So this is something we could easily move out, right? So trail defines not like trail right now is defining the request as well and the response, right? So you can define your trail to work with the trail request and response type, and then we can just swap around the implementations if we need to, right? Or provide some common functionality, but this is more of a specification really, right? How to do composable web apps or web servers or yeah. But it doesn't really say how we're gonna run any of this. It just says like this is how the application should behave. If you get you can't hear the music either. My guess is that 1, 2. I see something here. I see some activity. Magic, yeah. I'm gonna, yeah, that's good. Chalk outlines is really good as well. What is it? Oh, that's the album art. Thanks for the follow, Mr. Yahweh. Okay, so that was that. So if we move the frame there, then we could in trail define, okay, this will be the composable like socket, right? Interface. We could also leave that out of this thing entirely, right? And just offer that in here, right? Okay, let's define some of these things inside of Nomad so we can iterate over the API nicely. And then once we have something that's nice, we can move that to trail. So we're just gonna call this Nomad sock. We will have some arguments, and then we will have an initialization function, right? And then we will have our handle frame. So if you give us a frame and a connection, right, and our arguments, we will return something. And I'm doing this, this should be val, so like that. And this will be protocol frame WSockets. Nope. Protocol. We're gonna leave the build runner there. Build. Cool. We have a terrible API for this right now. Protocol. Okay, we're gonna remove that interface type. That should be fine. And then we have frame T, right? So if you get a protocol, a WebSocket frame, great. And then if you get, let's see what the rest of the connection is here. It's kind of like that, right? And the connection, and you get some arguments, right? Then you can return a couple of things. One of those is going to be push, right? And then we'll just give you a frame list. And we can start there. Cool, so Nomad MLI. It's gonna drop that there. Hello, intercoding. Okie doke. So we're just missing to string here, unfortunately. I think I'm just gonna remove that from here and manually add them to the interfaces right now. So we go into protocol. There we go. I like the OCaml at university. Happy to see it on Twitch. Nice. Well, happy to hear. Oh shit, yeah. If you do like OCaml, we should do a shout out. Forgot about that to Dylan Murray. Dylan DM Murray, who just streamed a massive 10 hours of OCaml and then rated us. So we did the switch. We're going for less 24 hours d'OCaml. Minus the typos. You get what I mean. Cool. So bench hello world. We don't have a normal request anymore. We actually have a trail request. And also in the normal test, we'll go there. Almost done. What's the problem here? Right. The make interface is different for the different protocols, which makes sense. So I think maybe we'll just say that a protocol, if we do that, then a protocol is just an Atacama handler. I think we still want to call it a protocol here, so the naming makes sense, right? Internally. Wait, that was the problem? All right, that works. So handler, what do we need this handler to be? And we need a module here that follows the interface of Nomad Sock. So that's going to be annoying. Jesus. Yeah. So the frame right now, it's kind of problematic, right? Because socket depends on WebSocket. So just hear me out. what if, just saying, what if we grab that frame and we take it all the way out of here into its own module, right? Cool. No more dependency cycle there. We have a frame. We can return frames as well. So now the only thing we need to do is figure out in HTTP1, when we actually are requested to do an upgrade, right? We will get our opts, like upgrade opts, right? We will get the module or handler mod, and then we will have the initial arguments, right? We're missing the initial arguments right now, so we're gonna add them to the handler here. We kind of want to do this with type args, right? So then you can pass the args there. But this type variable, right, doesn't exist anywhere. So we have to introduce one. And I think that means we will have to do a get here. So that way you can pack together, right, the module, the arguments, the upgrade options. I don't yet know if the H2C, right, upgrade is going to require the same thing or if it's going to be different. Because I would expect the H2C to work on the same connection, not on a new socket, right? But we will see. Well, that looks good, right? So now that we have that, we can actually pass in the handler to WebSocket make. And I guess upgrade opts. So let's go into the module, let's do make, right? We have a handler, we have some args, we also have some upgrade options. So we'll save all of those. Handler args. Yeah, I was thinking maybe we can call the initialization function at this point, but maybe it's okay for us to do this. So now our handler is not really handler T, right? But rather we use a module sock interface, right? We type args equals to args. So far as the arg here, it's going to be the same args. And again, that means we need another get. So I think we probably want to grab these two things and pack them earlier on, so we don't have to make everything a get everywhere, right? To be able to keep these two things together. Because we also want to be able to say the state has no types, right? Like the interface of an Atacama handler doesn't bring in any types, any type arguments. It requires a state with no parameters. And the upgrade options are going to be handler upgrade opts, like that, right? $55. So maybe in the socket, right, we would actually do T, and this will be our sock, and then we can push essentially this, right? We have a handler and we have a state, or args in this case. I think we'll need to change that to state at some point. Cool. And that means we don't have to do this here. We can just do socket right? Which is a little nicer. We can depend on that just fine. Okay. And here we don't actually have to split that either, so we don't need a get. We can just do handler, and this will be sock.t, right? What are we missing here? Oh, that. Great. Now HTTP1 doesn't have to do that. We just get a handler, so we just pass in the handler, and that works. And I think now we're gonna have a problem with the interface. Nomad MLI, right? And line 70, the problem is the module sock. So we'll do module sock, right? Module type interface. So we can do a make function, and we will take essentially a handler and args, right? And just do sock handler args. So that should work. Cool. Now the only thing that seems to be missing beyond that signature that we'll add to the interface here we need to actually add this, right, to the module here, module sock. Oof. What does it say? Right, we updated the handler, but we have not updated types. So Nomad MLI, we should have a handler module here. Oops, sorry. What does it say? Right, we don't have a frame anymore there. We do need a frame though, so I'm gonna drop that here. Line 28, this is saying, yeah, we no longer need that, right? The handler is not really a handler now, it's a sock T, I believe. So line 86 now, still complaining about this? We're missing the upgrade opts. And these are somewhere in the handler right now. There we go. Builds. Now we can go into the test. We can say the test is just going to be an interface, right? Which makes sense. It will be missing some things, I believe. But more importantly, here we will do sock make, right? And then we'll pass in the module, and then we'll say that. So if we did handler like that, it will be sock nomad sock make, right? We pass in a module echo server, and I believe this will just be a function from week, right? It doesn't know. Okay, that's fine. Handler. Okay, so I think if we make that this thing type, it might just if we remove the interface, but yeah, then that would be that. So we don't do OK here. And we just need upgrade options. And right now we have the dumbest options, which is like do upgrade true, but that'll change. What don't you like? Hmm. I know. Pretty amazing. I like the stories he tells. I think that's a problem. So we can probably define our socket all the way up there, right? There you go. That can be tricky sometimes to find. It's like if we don't define the sock module with an interface before the usage, right? Then OCaml, or I don't know what is doing that. I think OCaml is resolving that module to be like nomad double underscore sock, right? Okay, so we just need to make sure that we are getting here. All right, what's the problem now? And where's the frame? I think we just have a problem of declaration order here. There you go. I don't think this is gonna work. did not. It is doing stuff, but it's not calling our handling frame function, right? So if we go to the WebSocket now, Nomad, when we handle data, or rather when we handle connection, we call init on the connection, and that right now is not doing much. But look at this. This is a very similar interface, right? We don't really need this connection anymore, I think. So this is an Atacama connection, which is the actual socket. Let init, and we will get our socket here with the handler and args, and this args is going to become state so soon. So now we can actually call, right? Because this is a module, so we can do module handler, and this will be, I think we don't even need the interface there. Yeah, so we will be able to do init args, right? And we definitely want the connection there. So this needs to change Atacama connection T, right? But we cannot let that arguments escape, which makes sense. So what is init good for, right? It's good for telling us whether we should close the socket immediately or we should continue, right? But this init function is returning an argument here that we cannot really return from this function. And before, we were calling connection init, and this says continue and gives us back the connection, or gives us an error. Okay, so let's do that. We're gonna do init here, and that's gonna return either continue, right, of Atacama connection T. We can do that for now. So that's what this actually returns, which means it won't actually fail to, it won't leak the type, right? Atacama connection T. I think I'm gonna do an open Atacama here. Of connection, and then what is the reason supposed to be? Sharingan killer, they call me Naruto. Nice. I think I removed the wrong thing from the state here. Yeah, we definitely want to have the Atacama connection. We just don't need that connection module anymore. Dylan, a question for you, since you're also a NeoVim user. This is something that I've never been able to successfully search for. But sometimes, right, when I press I do something. I don't know what it is that I do, but I do something, and then Control D and Control U move a single line up and down. Have you seen that? And do you know what that is, and how to fix it? You have not. Okay, there is. Yeah, I don't know what I do, man, but there's something I press sometimes, and it just goes up and down one line, and I have to kill them and start over, which is pretty frustrating. Could be bumping caps. But I have the caps key mapped to control, so it could be. Seems unlikely though. That's all. Small problem here is that we don't really have a state initially, right? Or yeah, I could force you to have an initial state, but it kind of sucks. We could make it an option here just to get by right now, and then deal with the optionality in this like higher level handler. So if you get hit data for some reason, but you don't have a state, then oh boy, right? Like we're in trouble. So we can just do an option get. That could be fine. Okay. What I don't know what's going to happen is how would we actually specify the handler type here? I guess that will be defined by the module. Never mind. Dumb question. Okay. So we are missing here now a handler. And then whatever else we get, we just pass by. Okay, so that works, right? We pack and unpack the module for you, so you don't have to think about that, which is kind of nice. Gotta you. Yeah, I 100% need to do that at some point. Like it's been a while since I dug into how to do that config again, right? And I'm certain it'll be fun, right? And that if we sit down, it'll be like, okay, maybe I'll do a day of that and end up with an amazing config that I understand that is very very simple. Like, I want to go, you know, minimal on everything. I think, um, but that will help me. I should say debug things, troubleshoot when things go bad. Okie doke. So that works. And now we get a connection, but we also get a socket, which is great. So we can do this or handler. So now we just need to do sock handle frame, and then we'll do state handler frame. All right. That's fine. We can just do option get. What don't you like? Handle frame. We're missing the connection here. Gotcha. So when you handle a frame, right? What can you do? We can either send the frame back. Oh my god, this would be amazing syntax for defining the polymorphic variants, just like a list. That would be so confusing. Continue, right, of connection T. How do they do this on Elixirland, right? You got a WebSock P. Handle in. So that's our handle frame, right? And it returns with a handle result. Okay, so one of these things. That sounds reasonable. So you have a process, right? That right now is only handling frames coming in, right? No, I think we're doing everything on the same stack, on the same process. So you connect, and then we spin up a process, and that's happening at the Atacama level, right? We have a connection process there. Sorry, 3. We have a connection. So the connector, the connector spins up essentially a process. So this process begins with our default connection handler, which then does a protocol switch to HTTP1. And then as we receive data, eventually we have all the requests. And when we run the request, right, we have a handler. And the handler will tell us whether we want to continue. So if you're okay just doing HTTP, that's fine. You sort of maybe even respond. Or if we want to do an upgrade. And if we want to do an upgrade, the handler will tell us exactly what protocol to switch to, right? So the same riot process goes from connection handler to HTTP1, right, to WebSocket. Which I like because we can preserve the stack trace. So if something blows up, right, we should be able to actually see a stack trace that goes through all of these different layers. So the troubleshooting should be good. Let's try that. Let's see if that holds. What is the problem here? Oh, we're missing the connection here. All right. So this handler where are we leaking that error type? Here. We're gonna put something else here, like unknown opcode of int, since we already know that one. Why is she so mad? What don't you like now? So Nomad MLI line 38, right. We need more of this stuff. Cool. Wait, we have a handler module there. No, that should be fine because we're redefining it. So, sock, what don't you like? And we need to update the rest of the functions, right? So that one over there comes here. And we also need init. No, we don't need those. That's fine. This is internal. So line 96. We need the WebSocket. We're missing the connection here. Excellent. So we build the library. Let's see if we get the testing thingy here running. So state, we can do int. So obviously this will start to mismatch, right? So init takes a connection and arguments, and then we need to say continue, right, of the connection and a state. And our state is an integer, so we can do 0, which is fine. What? No, that built? That was that? Yeah, handling frame. Look at this. That worked. Okay, dope. So that means that when we start a Nomad server, right, we can build a handler, and that handler can switch to a WebSocket that use a specific module that we care, that we own, right, to handle frames as they come along. So what I'm failing to see here, because something blew up there, so we'll do a OCaml run param b, is why don't we get more frames? And my guess is that when we get the first one, we go into that error because we added a warning 8 to this bit. So we're returning push here, right? And this thing is not handling that. So let's see what that stack trace looks like. Ideally, it would be like, you know, handle frame, and then handle reduce while, and then I think it's going to be handle data, and then at least the Atacama connection. All right, not too bad. So Noma WSL, that's where it starts, right? And then we have handle data, reduce while, handler, handle data, connector, handle data, right? And this is sort of the first place, the last place in the stack, because we are in a looping function here. But yeah, we have our protecting functions here, and then we have riot spawn, which is the thing that spins up the process. I like this. I think this is reasonable. If you had many jumps between processes, it will be hard to debug what's happening, right? But since we have everything running on a single process, then that also means we can keep some of these things very fast, right? Very easy to debug while not sacrificing the concurrency. Ooh. So if you give us a frame, right, push frames, then we kind of need to push the frames. So let's iter. I don't know what the best way for doing this will be, but we'll get a frame, right? And we'll do continue. And here we want to do frame serialize, right? So we can do Atacama connection send, right? Connection frame. So if everything's good, we'll just return. We can even do return here. And we'll try. So first frame, right? If we get okay and we read it, perfect, we can do send frames, right? And then do frames, return. It's all good. If we don't, right? If we get an error of some sort here, then send should give us back one of those Unix errors. Okay. So we'll do logger error, right? Fun ff and we can do net socket ppr, which is a formatter for those errors, right? And then we can just say close. I think we have halt to finish the recursion, right? We stop parsing immediately if this is closed, but also we will return close, right? State. We have a type that we don't know how to handle there. That sucks. Didn't we just hear the song, listen to the song? Cool. That works. I am. What is happening here? Why is this frame text always changing like that? We're not using this code anymore, which is great. We don't really have a handler here. Love that. Love that. We switched to WebSocket. We won't have that. Need more data. We can remove that. Jesus. Wait, did we listen to the same part several times? I see there's many parts in one game. Wow, it really got me out of the code. Okay, so if we do close here, then I would expect that we would actually close the connection. What is this easy mode? I am gonna move that out. Okay, gotcha. Thanks for the clarification. Nice. Okay, so it opens and closes just fine. What happens if we do continue? Right, continue is just fine, doesn't really return anything. And then if we do error, Okay. As soon as we get the single frame up and running, I think it would be fun to look into the compliance testing with Autobahn. I know that Bandit is doing that right now, right? They're using this thing. And of course, the website doesn't work. But it's an automated test suite for the WebSocket protocol, right? So we can look at how it's been. Oh, look at that. Amazing. We can get Nomad here. That would be awesome. I guess Bandit is here as well. Can't keep up. Okay. We can submit it. Maybe they won't get it in, but that's fine. So, why are we seeing all this garbled data? We should be seeing just text, I believe. Like at the very least here, this frame, right? When we print it out, we're just dumping the text inside of the text, right? So I would expect at this point, the frame to actually just have clear text. Run.js, we are sending tests, right? So what happens if we send 0? What will we see? I'm considering that maybe we're sending UTF-8 text, and that's why we see this. Maybe the masking is not working. We receive data, and I can see that the first, 29, 29, it's the same. But then after that, this changes, right? And it makes sense for it to change because that's how the protocol works. So if we go into frame, right? So when we get a frame, it can either be one of these three. Either it's 1 bit for whether it's the last frame or not, 1 bit for whether it's compressed or not, 2 reserved bits, right? 4 bits for the opcode, and the opcode would be one of this over here, right? We have 1 empty bit and then a bit of padding, I believe. So maybe we're doing this wrong, the padding and stuff. Because up to now, we parse this fine, right? And we know that, okay, this is a text frame, right? And then depending on the padding, or maybe we're just ignoring the padding, right? We have the length, which is 64 bits, right? And then we have a mask of 32 bits. And that mask is something we need to double check. And then we have the payload. And the payload will be the length, which is the number of bytes. And we multiply by 8 because we need to specify it in bits. Yeah. Mentally wondering, is 1 byte 8 bits? Yes, it is. Just, yeah, one of those moments. So I'll double check the paddings that we have here and make sure that the rest of the layout, right, of each one of these packets makes sense. And we can do that here in lib, bandit, in frames, they have WebSocket, right? The serialize function, which is kind of handy here. So we get fin 1 bit, compress 1, 2, 4, 1, 1, 127, 7, 64, 32, and then the length uses the binary size, right? That looks fine to me. We might want to actually put a guard here as well. So when max frame size is 0, right? Or the length is less than the max frame size. And then length actually right in 64 less than so one thing, first bug, I guess. Second case here, 1124, 1126, 7, 16, 32, right? And the binary size length, just the same. Again, if the max frame size is 0 or we are within the frame size. And then the last use case we have here, last kind of frame, it's 11241732, 11241732. So far so good. And this is when the length is under 125, right? And I think, sorry, I need to do length by 8. No, length here is in bytes. Okay. And also the condition. So really, max frame size and length is something we want to check everywhere. But in this particular case, we're checking that we're also under that length. For every other case, we would need more data. Or not. So then we call our make function, which is kind of trivial compared to the rest. All right, well, let's start packing some of this information in these frames, right? Fin, compressed. I think reserve is just going to be reserved. I don't think we're even passing that anywhere. No, we're just matching on 0 there. Unsupported reserve flag. Okay. So we'll leave it that way. We'll do continuation of fin compressed and then payload. And then if we get text, it will be the same. And then binary is going to be the same. We can jump into these modules. Code and reason. And when we do the serialize, if it's true and false, okay, let me save those for now. These are booleans. So text, it's going to be thin, bool, compressed, bool, payload, string. Okay, got a little more data there. What you talking about? Nomad MLI. That's a very nice error, or at least it has numbered things and everything. Bool. What? What the hell just happened? Thin, that will be bool, bool, received. It's going to be an int. Gonna need to make that happen. And that worked. Cool. Okay, we're getting some more data here. Get 8 bytes everywhere. Why do we get 8 bytes? That's the whole frame we're serializing. Okay. So we receive this stuff. This is the frame that we put together, right? So the mask seems to be changing. And then the unmasking process is probably broken because it's giving us different sort of values. So I took that code, the unmasking code here, from the WebSocket AF implementation that Antonio forked. Specifically this loop over here, right? It has some modifications. So for example, we know that our payload is just going to be our payload. So it doesn't have the entirety of the string to do a source offset. It doesn't need to. Or at least that is the assumption, right? In the differences. So we can iterate from 0, right, all the way up to the length of the string. Offset begins in 0 by default. And I think I couldn't find anywhere where we're not doing that, right, with offset from 0. So I just said, okay, then the offset, the E the iterator here is going to be 0. And we're going to go to offset plus length minus 1. That will be 0 plus length minus 1, which is length minus 1. Now j here is the iterator plus the length mod 4. That was that. Okay. So j is really the mod 4 on I. That makes sense. So I think that if we try to send something else now, so instead of 0 hello world, we should actually read hello world, right, on the terminal. Hello world. There you go. That worked. Okay. We might have some issues here. But it's okay. Hello, iCode apps. Thanks for the follow. This reminded me. A million years ago, I actually had a blog called I Make Apps. I don't know if it's still around. Hey, Mikal, how's it going? Yeah, no, I'm not. Why would you change my name? All right, we tried. I got upset. Hey, Mikal, how's it going? Yes, Pinky and the absolutely Pinky y Cerebro in Spanish. They have that song that goes so Pinky Cerebro, Pinky Cerebro. Uno es muy malo, el otro no es tan bueno. De laboratorio son, el mundo conquistarán. So Pinky Cerebro, bro. No sé si está viendo en español últimamente, pero that's the one. All good code apps, all good over here. Is that the GitHub editor? Yeah, we're looking at some code on the right here from a library called WebSocket AF. And on the left, we have Vim and stuff. Try to take over OCaml. That's not what we're doing. We're not doing that. We're just contributing to OCaml. Yeah, so we have a bug here, el bugo. And I think this is happening because we're reading more. Right, we're trying to read more than we have. Okay, so it may be the case that our beautiful library for doing string pattern matching in OCaml like we do in Erlang or Elixir, it is not doing the thing that, yeah, it is being a little eager. So, but that's okay, because we could leave the payload parsing right until later, if that really is a problem, and just parse the header. Get the header out and then use those values to determine what to do. Because the length here, right, is one of the primary factors or things that changes. But we have fin compressed, the first 4, 8, at least the first 8, 12 bits are going to be the same, right? For everything, 112417, 112417, 112417, yeah. And then the length has just varying length. I wonder if that's a problem. Let's see. So in the stack trace, we get from here. Okay, so maybe not. 52. Is this because this frame is empty? Well, let's do some logging. Debug. Deserialize. Sorry, I turned the music off to sing that song, to butcher that song. Hey, Leia. There's a lot happening here. The serialize keeps being empty. Okay, we get a packet here. That's fine. So then we deserialize nothing then, and we receive some data. And that is also hello world. And then we try to deserialize nothing, so we just do nothing, right? Try to get more data. And we do one last deserialize nothing before breaking. So let's look. What is this doing? This creates bytes of string. So bytes of string is failing. No, Leia. Look at me. No. Go away. I'm gonna spray you. Person of internet. Hey, I don't make the rules, alright? I'm cat sitting. I was told to do that, so I'm just obeying the owner here. I'm following orders. It's just water though. She'll come back. So that means that at some point we bytes of string, right? And this blows up. Yeah. So maybe we will want to make a check if there is no data, right? Then we immediately just say we need more. No, not the problem. Hmm. Let's see if the bitstring lib allows us to just go. It's fine. I think it allows us to do checks, right? In fields. Yeah, we can do apply some constraint to the field. So we could do check. Now, Leia. Was that? Really? Is that how we check that we actually have a number 1 there? And this should be 26. And we just need 1 bit here. So this will be pad 1, pad 2. All right, that's a boolean. Okay. This removes a socket because we get an invalid UTF sequence out of somewhere, right? I just don't know where that's happening, but it looks like we have data coming in and out. My guess would be that the serialization is broken. It was broken at some point, so maybe we need to mask the payload, for example, in some way. Just like we have unmask, we may have the mask function somewhere. So let's look at that. This is plug. This is plug. These are some logos I was making for the templating library for Dylan. This is such a nerd. The laptop is backwards. The screen is on the back. Honestly, so much of the stuff that ChatGPT comes up with cracks me up so much. Just like the sheer incongruence, right, of what it says. Just absolute utter unpredictable chaos. Love it. But this was the one that I linked, by the way. Dylan, if you're still on stream. Yeah, I don't know. I figured you were calling me temple all the time, so I just went with that. And I used the right one as a base, which explains why they're a little humanized with the face and stuff. So apply mask. What if we follow a response cycle, right? Handle data, connection handle frame. Connection. So we have send frame. So this just calls frame serialize, which I think we have got open somewhere here. Nope, not that. We can also start closing these things. Hello, friend. There's many cables in the middle, Leia. What are you doing? Nope. Easy. It's okay. You okay? You wanna sit there? Okay, can do that. I'll just put you like this. Yeah, that's the stuff. Cool. It's a win-win, okay? So, serialize. This returns an IO list, Ryan's favorite data structure. What I don't get is why we don't get the message logged, right, on the JavaScript side. We are saying on message, just log that thing. But maybe we need to do that on connection, right? On connection, and then we get a connection here. Otherwise, oh, okay, I don't think I'm doing that. So when we do serialize the frame, I am no, yeah, I'm not doing that. So we got fin, that's good. We got compressed. We got the reserved bit here, which is 2 bits, right? And then we have the opcode. That's fine. But then we're missing our mask here. No, wait, the mask is here. What? And the mask is when the amount of bytes, let's see if we did that right. The byte length by 8 is bits. I think we need, we will need a different, yes, we need one for, this would be bits. Bytes 8. Bits. No, bytes 8. That makes more sense to me. So then if the bytes are under 125, right, then we do that. If they're under 65,000, then we do this thing. Else we do that. But in any case, we will not use bytes here, right? We will use bits. Okay, so that could be another discrepancy, a difference, right? Why are we showing just hello world when we do serialize? Oh, that's a payload. What about you show me the entire data or frame? Is it expected to be this way? To just be a clear data? Invalid WebSocket frame. Nice. Wait, so there is a framing? Chat, do I need to mask my WebSocket frames from the server? Okay, so we're just gonna go and do the dumb thing. Chat.ocaml.ai. You'd be surprised at how good at pointing out bugs sometimes it can be. So the error invalid socket, WebSocket frame, invalid UTF message sequence typically indicates a problem with the encoding of the format of the payload sent by your OCaml server to the WebSocket client. Let's analyze your OCaml server to identify potential issues. The unmask function in your server is unmasking the payload correctly. Ooh, look at that. However, it assumes that the payload is valid UTF-8 string. If the payload is not UTF-8 encoded binary data, this could cause issues. If your server is meant to handle binary data, you should ensure the binary frames opcode are not treated as UTF-8 strings. Hmm. It even asks for the logs. We can go here, just make that smaller. Hey, Akram Dev, thanks for the follow. Okay, so if that is the case, right, then maybe when we grab the rest of data here, or the entire payload, we want to go into our make function and say, if you are text, we are actively going to try to parse you as UTF, right? And do that. How do we do that in... I guess in Minty we did something like this, right? No, wait, in TDY. And here we would have a standard in module, right? Where we use UTF decode and try to decode the buffer. But I think it'll be easier now because we have an entire string. And at this point, it should be the entire package. So that's good. So let's do that. Tune in Nomad. We're gonna bring UTF as a dependency, right? So now we can do what? No, there you go. Serialize, make, right? UTF, and I think hopefully we have a decode this string, right? Function, so we can just reuse that. Okay, so we will have to use that, and we need a decoder, and we can use a decoder of something. How do we get a decoder? Oh, that's a function. Okay. So let's do that. Decoder, UTF-8 decoder, right? And then we will pass in a source, and I think the UTF source, great, string, perfect. So we can just do that and pass in the payload, right? So that will be our decoder, and then we can do decode. Decoder. And either we get await, end, or malformed. So at this point, I would expect it to be, wait, this is one character at a time. No, I want to get the whole thing. Decode. Do I need to build a buffer and put things in that buffer? And we need to iterate. So match UTF decoder, right? And if we get a character, then we have our character C, and we want to do UTF buffer add, right? UTF-8, and that will be our buffer, and then our character, and then we'll just call field buff again. And then eventually we'll get to the end, right? Which means we do nothing. And if we get everywhere else, and especially if we do fail with, right? And what's it? No, malformed string. We'll do logger error fun f malformed payload. And the other one would be should never wait. We were gonna fail there. We really should never wait. We have the entire source already in memory, so it should be, we shouldn't wait. Okay, so now we can call field buff, and that will give us the buffer, right? And then now we can do buffer contents and buff, and that will be the payload. And this should be uchar. Okay, so this should be, assuming it works, right? We're gonna log this out just as an error here. Pre UTF payload, then we do payload, and then we do UTF-8 payload or post. Cool. Run that again. Let's see. So they're all good UTF values. So why are we not sending them as UTF-8 values? What is the problem here? Invalid frame, invalid UTF-8 sequence. Is this the thing that's destroying our payload? So maybe we want to concat those two, or just want to do let payload, it's going to be bit string, right? Bit string of string payload. No, that's fine. Data message. That is not working as expected. I don't know, chat. I don't know what else it could be. So I'm not seeing any of the data that we get, right? On message. Maybe we can send an emoji, right? To see if the UTF-8 encoding is actually something that we need to keep or not. No. Okay. We blew up. Bad field value. Right. That's weird though. Oh, it's in the serialized part. No, that's fine. Serialize. Oh, nowhere. We definitely don't get close to that. Construct failure, bad value, no match frame, not 119. So it's here. Why? Why is that there happening? Okay, so this is the one that's not working. Bits, because maybe it's more than 8. Hundred and 25. $16. Okay. Okay, I'm gonna double check that kind of masking here because I don't know if we're checking for. It doesn't. I don't think we should be checking for bits here, right? This sounds like the in 16, so 2 to the 16, right? Yeah. Seriously? Oh, fuck my life. That was sheer luck. But it works. We have it. We have the thing. Woo. Yes, yes, Leia. Mwah, we did it. We can send frames back and forth. We can reply to things. So we don't really see the thing in the Node.js box, but we can fix that right now because we got a message. I think this would be to string, maybe. Yep. Woo! WebSockets, everybody. WebSockets. You get a socket, and you get a socket. Oh yeah. Oh, where is it? Clip that. What? It should be available. Why are you not available? Clip that. Boom. Lipo Pete. Hey, Metami, how's it going? I didn't see you there. What you're seeing here on screen right now is a WebSocket server running on Riot, connecting and sending and receiving frames. We did an echo server. And not just that, we build it so that in our test, right, you can actually build your own server and plug it in and say like, oh, this is what I want you to do every time you get a frame. Were you framing? Were you napping? Hey, Nightshade, dude. Are you ever not online? I'm always afraid that you're there and I can see you. I don't know why, though. I like you. Maybe. Just maybe. But this is just... It was very frustrating. And this is the part where if I go to the RFC, it will be pretty obvious that the error was that. But we're always handling the length in bytes, right? I mistook it for needing to push in the amount of bits, right? We don't need to do that at all. Oof. Cool. So we're going to come here. Oh, when we clip that, it actually sends you a clip. Can I modify the clip? Don't know how to do this. We'll have to figure that out some other time. What I wanted to do was to record something that showed that. But I guess this will have to do. Save to clipboard. I am very superstitious, so I would not do that. So, okay. This is fine. We can remove a lot of the debugs here that we don't really need anymore, right? Frame parsing, we do errors. We don't need to do that anymore. I actually wonder if we need to do this at all. Like we're getting data, right? Yeah, that's fine. So my guess is that we might need to enforce this if we're constructing data, right? When we create a frame and we don't know that the frame does not have a UTF payload. But I'm hoping that we'll be able to move this UTF-8 handling to the IO buffers. Those buffers are going to be doing a lot of heavy lifting for sure. Cool. So where are we doing receive data here? That's in Atacama, isn't it? Yeah. Hmm. Did I not save the files? I did. So why didn't this install Atacama again? There we go. Cool. We can always go down to trace, and that would be noisy. Yeah. Okay, so now that we have that in place, I want to move all of this upgrade stuff and the definition of a socket handler, right, out of Nomad, and we'll put that all in Trail. I think, because I kind of would like to have the parsing of frames right here, right? So maybe the frame definition. Ah, but that sucks. To have the damn it, Jesus, to have the frame definition in a different package than the parsing, right? But I also don't know if it makes sense for Trail to own the definition of a WebSocket frame. You know what I mean? Like if Trail is gonna let you plug in these functions and build your little pipeline, right? Then it needs to know, like if it's gonna include a socket interface there, then it needs to know what the hell is a frame, so that you can get a frame, right? And you can do something with it. Hmm. I guess we already have a request and a response here. It wouldn't kill us to have a frame. Oh, yes. Let me catch up. So yesterday, right, we started working on WebSocket support for this library called Nomad, which is the here. It's sort of like the HTTP web server, right? That I've been building for Riot, and it's inspired by Bandit, and there's a lot of things that they have in common, right? Because there's a lot of things that we have in common now that we can write process-based code, right? And we started off with just HTTP support, HTTP1, and then we built a couple of nice things. And this will be a nice recap. If you were here at the beginning of the stream where the screen was frozen, right? We we did a quick walkthrough, right? Where one layer below we have a socket pool called Atacama. Let me search that up here. And Atacama's job is sort of to say, well, if you give me a socket, right, I will listen with all of these acceptors on it, right? And then the moment I have a new connection, then I will just spin up a process to handle that connection on its own. So, in isolation, that connection will be handled concurrently or parallelly, depending on how many cores you have, right? But this is very raw. It's just echo, like, TCP sockets, right? So you need to actually teach it protocols. So to do that, we started building Nomad, right? But at the time I had a problem, which is like, if you are doing WebSockets, you first need to connect, negotiate a protocol, right? And then do an upgrade. So we have to do a series of refactors there to make it nice. And right now, if I walk you through some of the Nomad code, I think it's pretty beautiful and it's really straightforward to read as well. So there's a connection handler where everything begins, right? So every time you get a new connection, then this is it, where it starts. And literally we just go through a negotiation process where we return what protocol we want to work with, right? And that's just a module. So it's really nice, I think. So if you start in any protocol, and I think by default we start on HTTP, when we go through the negotiation, right, you may end up in HTTP1 or HTTP2, right? So this switch here allows us to swap out the handler of the current connection at any point in time in the lifecycle of the connection, right? So this takes you to the HTTP1 module. And this is a little more crowded because it has more stuff. But roughly speaking, when you're handling the data that comes into that socket, right, we're going to do a little bit of parsing, and eventually we will have a request. And when we have a request, we call run handler. And what run handler does is that this runs essentially your controller code, right? But still at a very low level. So at this level, there's still no like routers or stuff like that, right? It's just, here's the raw HTTP request, right? And here's the socket, the connection. What do you want to do with that? So either you continue, which right now, it's disabled, or you upgrade. And when you do an upgrade, then you can say, well, I want to upgrade to a WebSocket, right? But that is completely up to you. So in the WebSocket example we have here, right? The handler code here could be doing things like match on the request URI, right? And be like, oh, if the request URI is like WebSocket, then we will do an upgrade or whatnot. You don't want to do that manually, right? But you want to start with it being done manually so you can put layers on top of that, right? So now we can say, I'm going to upgrade this connection to be a WebSocket. And then you just give us the handler, right? The name or the module that would be used to handle that WebSocket connection. And when it comes back, we do the right protocol switch to the WebSocket protocol. So now this is some of the new code that we've been writing today. When you get data, you do the same kind of parsing as before, but now we parse WebSocket frames, right? So we wrote a parser for frames here using the bitstring library, which is beautiful because you can do pattern matching like this, like you would do in Erlang or Elixir. It is not as powerful, but it has a couple nice things. And I think in some ways it's more powerful as well because you can run, in some places, arbitrary bits of code. But this helps us say, well, these are really the three cases, right, of valid WebSocket frames, right? And when I compare this with, like, for example, parse combinators, this is just day and night. I can read this. I can look at this and be like, okay, 1 bit for the fin sort of marker, 1 bit for compression, 2 reserve bits, 4 bits for the opcode, right? We had a padding of 1 bit that should be true, or literally the number 1, and so on and so forth, right? Yeah, 100%, right? So we did that, and the last thing we did today, right, was to come up with the right abstraction to be able to say, I'm going to use this module, right, to handle incoming frames. So if you're a user of in this case, Nomad, right, and you want to build a WebSocket server, you just need to define this thing, right? And then all of the handling here takes care of that for you. So I feel like that's pretty nice. We still need to build some more abstractions on top of this, so to be able to say like, well, I will have like a router, right? Where if you go to WS, then we will use the Echo server, module to handle the WebSockets and stuff like that. But this is the raw pieces, right? So if they are there, then we can definitely shuffle them, put layers on top, and just make it really easy. Yeah, so that's a little bit of what we've been working on between yesterday and today. Yeah, the idea is to get this sort of vertical slice up and running, right? So we can we can build something like live view in Elixir, but in OCaml. Now, the next level there would be to be able to write the front end code, right, in OCaml as well, compile that to JavaScript, right, and then have this socket sort of just be type safe. And I'm so excited about that. I can barely contain myself. It's just crazy. Yes. I've had to do more gats and existentials that I wanted, but impressive translation of all those things from the Beam ecosystem. Thank you, thank you. For those of you that don't know me, like Lindux does, I've been an Erlanger for a while, and I've been writing a lot of Elixir as well. And he and I we've worked together some places, um, and I love the Beam. I really really like it. It's just the types that really sort of make or break my ability to work at larger scales, right? Not saying that that happens for everybody; it just happens for me, right? I know that other people agree with that, which doesn't mean that it happens for everybody, right? Um, so yeah, I think somebody was saying earlier today that I am misrepresenting some of the other ecosystems, right? Like I don't want to misrepresent any platform here. It's like we're trying to communicate you that you already are misrepresenting, and not just one or two, but almost everyone. And I don't think that's true. Like I'm not intentionally going out there and saying like, oh, these platforms are worse than, right? There has been one tweet that I did, but you know how Twitter is. You have to be a little baity. Um, where I said, oh, I guess OCaml is better for networking than Go and Rust. And a lot of people lost their shit, right? And I'm just saying it tongue in cheek, right? You can build amazing things in Rust, and I think a lot of people build amazing things in Go. I don't know if I could, right? It's not my kind of language, but people definitely do. We use a lot of Go tools, right? Daily. Yeah. So like someone saying like, oh, if you use IO copycon instead of rewrite, there's 3 times the performance. Amazing. Let's PR the improvements. Like, let's do it, right? I am just using this little benchmark readme here right now, right? To have an idea of how is the relative performance, right, changing on my machine when I run it like a couple of times, right? On the changes I make. If I really wanted to make this a proper scientific benchmark, then I would go to something like, I think I listed here Tech and Power, right? Which seems a lot more serious than what I'm doing. So I would submit here and I would say, okay, benchmark us, whatever you do, however you do it. You see a lot of frameworks and stuff here. I don't know what GNet is, but it looks real fast. Wow, this is Go? Amazing. Damn, now I want to get something in here. We're probably not going to be even remotely up there, right? I would be surprised if we're like in the 0 point this range, right? No way, Phoenix Bandit is here? What the fuck, seriously? That cannot be true. This must be wrong. Yeah, yeah, exactly. People, yeah, out of indignation submitting PRs. That is kind of what I'm trying to do. Is like, all right, if you can do it better, do it. But otherwise, I'm not an expert in everything. But I cannot be an definition, but an expert in everything. Trolling for PRs, yeah. We got some actually, and we got them merged. So if we go back to here, pull requests. Out of the three, I think two of them. No, even yeah, no. Well, one of them is just an image that Morimoto added. But for example, Glepom here, right? Says the benchmarks are way too synthetic, mostly depend on proper tuning of buffers, right? And then I merged that because it was a good improvement. And then Ryan did some work on the Elixir benchmark, and I merged it because it was a good improvement. Okay, I'm more than happy to have tech here that would show me like, okay, release after release, how are we doing? But people seem to expect me to go out there and out of malice say like, oh, your language sucks. And it's like, no, that's not the case. See, like people are saying like, you remember to update it to use 50K buffers. It's like, dude, like, have I not made myself clear? We'll update the buffers. No problem. Like, that's the whole point of putting it out there, right? People can point out that something is wrong and then we fix it. Like, what is the problem? Software does not have to be finished to be published. I get so angry at that. Yeah, let's do that. The buffer size here. I think the buffer size we're using for Atacama by default is 50 kilobytes, right? So we'll do that. We'll update that. But like in the time it took them to write all the chunk of text, it could have been like, oh, hey, here's a PR adding this little thing, right? Try it. Try to run it. So we're going to run it. We ran all of these things on stream. We didn't run anything privately. So none of this is like, oh, Leandro is being secretive about how it runs the things. No, fuck that. And Eco EIO, we don't have that bench. We should have it. We're gonna do separate. Yeah, see, we did have it at some point. Gonna split that. Modules, echo. So we should be able to run that. Note that we changed the buffer there, the buffer size, to exactly what was being advertised. So to exactly the same buffer size we're using, right? And on my machine, in these conditions, we did it right now. We could run this 1,000 times for all I care, right? It runs at roughly 90 megabytes per second. Great. If we run the Atacama one, something is broken here. Like literally, this is not booting up at all. Echo. See, this is how secretive I am about this. It's like, we just ran it and it just didn't even connect. Why though? Why didn't it connect? Logger set log level. Some debug. Let's see that. Oh wait, sorry. We're gonna run it in release mode. I think that's more fair. Yes, you probably noticed that every time you, yeah, I need to take the extension and replace it with X. So this is 125 megabytes, which is better. We had 100, maybe 25% extra. Again, we're just running it like once, right? So now I can run the other one and we'll see the numbers and we'll see. So this doesn't seem to be working. I think the current version of Atacama is broken. So why are you broken? So you connect, but you don't handle the connection? Acceptor pool. Okay, well, let's do some tracing here. And we'll see what's happening. We don't see anything, fucking anything. And I wonder if I have on. Yeah, sorry. Sorry, I have another server running here. What? How did that work? How did the EIO one work? All right, once again, EIO. $160. It's going up. So we've seen EIO go from debug mode at 90 to a weird run, I guess, at 125, right? Which I had some other server running. And when I closed that server, it went to 160. So I was like, twice as fast, right? And now I'm going to run, let me just do a telnet check to see that this does work. Okay, that something is happening there. Cool, all right. So that works, right? So now I can disable the tracing because otherwise it would be crazy verbose. There will be so much logs. We can run it again, right? So remember, 158 for EIO, right? $358. I mean, is it a scientific benchmark? No, and I've said it 1,000 times. But come on, this seems to be running faster. Why? It may be that the way that I've designed Riot is just more efficient for this kind of use case, right? Which I think makes sense. Hey, Popcorn. How's it going? All good? We are right now, we're building things in OCaml, in the OCaml ecosystem. We just finished our first tab at a WebSocket server built on top of an actor model runtime called Riot. And we were, after that, going through some issues in one of the projects where people were mad at the benchmark being unfair. And even though I've repeated 1,000 times that this is not a very scientific benchmark, it's just something I'm running on my computer, right? And this is mostly for me to understand, like, oh, did I fuck up the performance on the thing I'm building, right? Or not? And I welcome all improvements. In fact, we've had improvements on the Erlang and Elixir side and also on the Rust side, right? And yeah, if these numbers don't make sense to you, that's fine, right? Come here, we can fix them. But this is not tech empower, right? No worries, Linux. Have a good one, Mikael. Say hi to the family for me. Yeah, I think so. It's a lot of fun to build. And I think if we build the right layers in some, with some semblance of, let's say, alignment, it will be very straightforward for us to build a lot of higher level things, right? That many ecosystems have that are hard to get right now. Like all of this thing that we're doing right now started because I wanted to do a web crawler, right? In OCaml 5 with the EIO, the multi-core scheduler. and it was too hard. It was too low level. Like, I don't want to think of threads. I don't want to think of like scheduling work and putting things in queues that are shared and that sort of thing, right? Which is ironically something I've had to do to get this scheduler working. But when you have something like the actor model, you can just say like, oh, I'm gonna start just, you know, processes that do requests, and I don't really care when they run or where they run as long as they run. Very, very um, sort of goals as well. Yes. So another thing I wanted to test was, can we continue doing regular HTTP connections? Because if we have a handler that says continue, then we just want to do continue, right? Not close. That was a lot of failures. Connection closed before message completed. All right, because we're running the WebSocket test. Sorry, if we go into the Nomad test, that should be the first one. And this is more of a regular, like just a handler, right? And we're building an HTTP request, and then we respond with that. So we can do curl on this. Okay. Oh, I think we probably want to close the connection here. So either you upgrade or you close, which means you have handled the connection in its entirety. I think that was that. Let's see. So we had a hard limit on macOS, and we spent an entire stream, like, I don't know, 12 hours debugging that crap. You can only have 16,000 have open TCP connections on macOS. For some reason, you cannot change the number, and if you do, which we did, you cannot change safely. But if you do, as we did, you will kernel panic the hell out of your machine, and we did that on stream like 3 times. Literally, I had to reboot and rejoin the stream, right? But I think now that we have that in place, then the socket closing, then it should be easier for us to say like, all right, run for 10 seconds, right? Wait, I forget. Is it T? Oh, that's a timeout. How do we do duration here? Z duration. Okay, pretty unstable performance. We did get 16,000 connections and then something broke. So maybe that was not the problem. Oh my god, I thought my computer froze again. I was like, no, no, don't do it. So latency is pretty terrible right now. 30 milliseconds for a hello world is pretty bad. Especially locally, right? Like I would like to bring that down to like a single digit millisecond at least. At most, I mean. But at least we can now run 10,000 connections and get that data, right? So you know what? We're going to do this. We're going to go into the NOMA test. When we say debug, we're going to actually do info only. And we're going to move that to the right. And we're going to open instruments. And we're going to do a little bit of benchmarking here. Sorry, profiling. Well, instruments is broken. No, just open it. I said open the instruments. Seriously, computer? Reopen. Oh no. It looks like we can't open this. That took a while. Okay, I'm gonna cancel that. Not bad. If 100,000 requests, 95% of them are 14 milliseconds or lower. The yeah, the higher ones are just terrible. But oof, that is not very good. No bueno. Look at that. That's okay. We're just getting started here, so don't expect this to be absolutely amazing or just beat well-established alternatives, right? Just yet. We did though rerun the Atacama ones, so let's update that. That was the last run we had for EIO in 10 seconds. So we'll do the 60-second version now while we update this. 1:58.2. What do you mean IO copy doesn't exist? Go IO copy. Oh. Strong. It's going down like crazy. I don't know why, but what the hell? Why is it dropping so much? Oh, this is the 60 second. Cool, I like this. It's not that different from what we have, right? We don't need this, we don't need that, but we need log and we need other. Come on, I want to be like wowed. I want to see the number and be like, okay, I would like to be able to get there. So 200. It's the same. 191, 199. Yeah, this is a buffer connection. Does it use no libraries from the outside? Willing to give it a shot. What the hell's prefix? Oh, we don't have a prefix. Oh, just do bytes. Now we're talking, yeah. We have a buffer reader now, right? But this is not writing shit. Don't get it. I would expect that to work. What? So we do read, but we have a buffer here, right? So new buffer, new reader. No, I don't want to do a new reader. I want to do just gets the line. Right, the problem here is that byte at the end. I wonder if that's going to be a problem if we call so when we do buffio new reader, we can call fill on that. Let's see if we can get a I guess go PLS. Cool, it's installed. So we do reader.fill. No. So let's just go to the docs of Buffalo, go to dev. Let's see how that package is used. Hopefully it has some examples. We won't really want to do a lot of things. We just want to like fill the buffer, whatever the buffer size is, right? And then we just flush that out into the same connection. Go Buffalo pipe reader. Okay, so it looks like people are making buffers like that. Okay, I have to be doing something wrong here because this is terrible. Let's see, bigger buffer, better. I don't know. I'm trying here, but this is barely better than the last implementation we had, the first one, which is what seemed the dumbest. Even IO copy like that. Okay, let's see if we can do the Go TCP server. There must be a library somewhere we can just throw and just use, and it's kind of nice. Um, and it's fast, right? Okay, maybe not this one. Gene TCP echo server. Maybe Gene has something there. Oh, there's an ATP framework. But we can look into what this uses for Gene Gonic. That's funny. For TCP, right? Okay, let's ask the GPT. I want to build a TCP echo server in Go. What frameworks or libraries do you recommend? I think it makes sense since we're using libraries for every other language, right? Hmm, maybe not. So, what if I need a connection pool? Just give me. Hmm. When's the last release? Years ago. So Go, Fei, Fati, Pool, alternatives. No, what the fuck? Seriously? Connection pool. that's a big buffer. Should be 50. That's what everybody else is using. Nice. Just to see if we bump it up to 500, how much throughput do we have? Oh, not that much more. So that must be the sort of near the peak, right? 532.8. Sorry, 532.8 here. And if you run it for 60 seconds, then my guess is that sorry, I need to bump the buffer down to 50 again. Oh, right, release mode. Ooh, nice, 538.9. And now we can do 60 seconds. That is surprisingly stable. So it must be saturating the network stack here, which is good. If that's the ceiling, then that's as close as we sort of want to get, right? Okay. So Dune exec EIO echo EIO release mode. So this is our client with up to 100. No, maybe we don't want to say max connections. Unless the max connections is okay, that's a lot of connections. Yeah, we can do that. What else? Read flow, max. Yeah, that should be your buffer. And then we spin up all the threads, right? And then for every thread, we have a switch where we're listening to the port, and then we run server run, listening sockets. We get a socket, we do run server. By default, S runs on a single OCaml domain. If additional domains domain manager parameter is given, then S will spawn domains. Oh, okay, excellent. Yeah, that's what we want. We don't want to do this thing ourselves. So we will pass in domain manager, right? And we want to pass thread count. Essentially, we can do that here, right? So additional domains, then that needs to be what, a tuple, right, of the domain manager and the thread count. Cool. So that probably means we don't need this stuff anymore. We don't need to fork there. We do need a run maybe, but we can probably just end there. We don't have that because we don't have a thread ID anymore like that. Let's see if we can run it now. No, a little bit of type errors. Perfect. So domain manager is the first thing we pass in, right? Do we need to run the domain manager like that? No, we don't need to do that. All right, so let's see if that works, if it does something. Climbing up, nice. Wait, we have double switches there. We don't need that anymore. What else do we have? Reuse port, backlog. I think we're using a backlog of 100 as well. Riot. Okay, so sounds like we've removed all the low-hanging fruit. Come on, do your thing, EAO. Oh, we're running the 60-second one first? Okay. One 73.3. And then when we run it for 10 seconds, maybe I expect it to be a little higher. But I don't know if this is forking, right? Every request. I would hope so, but maybe it isn't. So run server loop. Yeah, accept fork. Okay, so it is doing that. So we accept and then we fork. And then we close the flow if we need to. And in this case, the flow is socket. And then we have fiber fork, and that's sort of the running of the handler and stuff like that. Nice. Okay, so that was 149. We can leave the old number, that was better. I'm on running it again. Because maybe it was just a bad run. I don't want to misrepresent anything. 157, okay. 0.0. Chat, does any of you know any Go? you don't help me, you don't get to complain that the numbers. If any of you has all the Linux numbers, I'll be happy to add them there too. Maybe it's a little too aggressive. If any of you has all the Linux numbers, I'll be happy to add them too. I am resisting debate. Seriously. Hi, folks. Clarify some stuff. This is just a way to compare how Takam is doing. The numbers themselves are not that important. It's the number relative to the. Any background loud will make your testing hide and shut. Yes, that's okay. That's okay. That's completely okay. I don't. How often do I have to say this? It is completely okay. That's not the point. Maybe I'm missing something. Maybe the word I'm using just triggers something people that think more scientifically than I do, or that require that scientific thinking. Goes without saying, but if you can improve the on the EIO or Go code, just do it or tell me how to do it and I'll get it done. Super happy to. Okay, cool. So we close that angry part of the stream, just being angry at the internet. I still don't know how to do this in Go. I couldn't find any good framework for doing that. Like something like Tokyo, right? You would assume that it's because in Go you have primitives for concurrency and they just expect you to use, the buff reader and deal with the connection directly. Maybe that's the case. Maybe that's why no one has built an abstraction, right, that lets you do an echo server, right, in a sort of pool or something like that. Yeah. Now for EIO, I don't know what I'm missing because I'm using their default server, right? And I am using a copy from Flow to itself, right? which, as far as I understand, should be the same syscall that I'm making. So maybe it's a problem in how they're scheduling the work. All right, we're gonna go into something else. I'm feeling like Arctic monkeys. Arctic monkeys. Sure, just hit me up with whatever you have. Really, your poor. So my guess is that in Atacama, I should probably get the acceptor pool right when it listens to not reuse the socket. Cool. Nice. Yeah, so this is doing fine. It's a little messy, but it is doing fine. So the thing we wanted to do here was to start moving out of Nomad all the stuff that has to do with the frames and whatnot. And I forget why we went from there to where we were before. Like before now. Oh yeah, this is 100,000. That's a lot. Right, I think we have still some bugs with the connection not being closing, not getting close correctly. Connection refused. Oh yeah, we were not running the server, of course. There you go. That makes more sense. Yeah. Okay, let's have a little look at that and see if we can fix that before we move some stuff out. So we want to go into the first normal module, normal.ml, right? We are start using the connection handler here to start an OCaml pool, right? And we don't really set a buffer size and stuff like that. We're just like assuming you know what you're doing, or rather, the trusting the system. We really wanted to run instruments, but that sheet is broken. Failed. I wonder what did I break for this to not work. But okay, so we have the negotiator protocol, right? And I wonder if something here is slow. There is a lot of stuff we're doing that very poorly here, right? Regarding formatting the responses and parsing things and stuff like that. So I would not be surprised if that was over time adding a lot of overhead. But I need instruments to check that out. But otherwise, if we cannot negotiate a protocol, then we close the connection. That's all nice and dandy. And then we jump straight into the switching, right? So we will call handle connection on HTTP1, for example, here. So if we do info, then we should see that. Yeah. And that just says continue. We have nothing to do here right now. No work on the state, but we could have some work on the state, like initializing the request ID or whatever, right? And then we have handle data. If we are not done parsing, right, then we continue. If then we're done, then we're done. We just call the run handler, right? Otherwise, we continue. I think we probably want to just stab a close there for correctness sake. I wonder if we do like hyperfine on this, how bad it will be. That's a lot of overhead, right? But yeah. Cool. So in the last case, if we are to continue, then hey, positron. I am writing OCaml, so this is OCaml for you. Screen. I am writing an HTTP server that runs on top of an actor model scheduler that I've been writing for a couple of months called Riot. So Riot lets you write OCaml like you can write Erlang or Elixir. So create a million processes and have them communicate and stuff like that. Earlier today in the stream, we actually got WebSocket support for the server. Sorry. Shrink, WebSockets. What do you normally work with? Or what's your background? Or what do you do? Games. That's cool. Anything I've played lately? That's probably. I mean, unless you work on Dota 2, then probably not. I don't play a lot of games. That's more of a dunk on myself than it is on you. Android and iOS. Cool. You know how Swift recently introduced actors? Have you had a chance to use them? You hate Swift? Oh, no worries. Languages. You develop primarily on C sharp. Cool. Have you used F sharp? JS, PHP makes sense. We will have to figure out how to do reading of body here, which we don't have yet. So the run handler, right, just converts the request, right, from HTTPF into the trail request, right? And we may want to have something here like the body reader. So when you do body the first time, right? I guess we don't have something like on access, right? But you could call it, right? And if you call it, then we can use a lazy in there to actually fetch the body, right? And then memoize. No worries. My English is also not perfect. This is my second language or third, um, but it's the one that I use the most when it comes to programming stuff. Good to have you in the stream, though. I'm trying to understand where the hell, right, could we be maybe not closing a connection or something like that, right? Thanks. I have put a lot of effort in at least sounding like okay. When I started my career, I had to do a lot of work remotely, and just being from Argentina, from South America, instantly meant that um, people assumed that I would be a shitty coder because I was just so much cheaper, right, than the people that I used to work with, right? So working on my accent actually helped in a lot of cases where I had to pitch myself and say, "Hey, yeah, I can do this. I can, build something," just to get jobs, right? Oh, thanks for the follow. Even need a deep end, keep imagining. Yeah, I'm from Argentina. Hi, Frey. How's it going? What do you thought I was from? I go crazy. Here's where I wanna be. No me digas, ¿qué se llama? ¿Todo bien? So maybe, just maybe, right? Atacama is doing the wrong thing here. So let's go into the connection. No, connector. And we'll look at what the hell do we do when we get a close. Okay, so here close should clearly be. No, that should be fine. Because then if this entire function call, right, ends prematurely or not, we will call net close on the connection, right? You thought I was from the US? No, 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 no. I'm not from the US. I am from America, the continent, right? But I am not from the US. Yes, my native language is Spanish. I also speak Portuguese, um, well enough for me to be able to say that I speak Portuguese. Você é brasileiro? Tá bom. Yeah. I have a couple of books here that I've been reading. Let me fetch one, actually. One sec. Ideias para adiar o fim do mundo, de Ailton Krenak. It's a small little book. It's really nice. Yes. Uma parábola sobre os tempos atuais por de nossos maiores pensadores indígenas. It is the kind of book, like, it is very deep. It's so small, but it's so deep. Like, you read a chapter and you're like, fuck, I need to think about this. I need to, like, reconsider stuff and so on. Are we going to listen to Bad Bunny on stream? Let's do it. Bad Bunny. Boom. Monaco. Maybe I should stream more in Spanish. I know it'll be fun. We will definitely curse a lot more. And yeah, we would always be switching to English to say words like connection handler. Yeah, positron, just hang out here. We can speak Spanish. This is cool. I like Bad Bunny, but I want to show you the stuff that I listened to growing up. The kind of music that when it plays, it immediately takes me back. And I mean, I'm already smiling. This is just gonna be so much fun. Add to queue. We're gonna start with that one, and we'll see where it goes. Oh wait, maybe we should be doing the handler close here. Do we have the context? Yeah. So handler. No wait, the handler close happens when in the pipeline. What the hell is handler close? Anyways, handler. The common handler. We need a handle close. So when we do handle data and we say close, then we need to do handle close, and then you get the connection. But this has a unit, and then here we can do net. Can we do? I think we should do connection, right? Connection close, right? We should not use the socket directly. We have the connection here. Oh, how the hell do we do this? Because we no longer have a connection object, right? We now have like a reader and a writer. So maybe we want to keep a socket around here. God damn it, we'll need to figure out how to create a new empty socket. But I guess we don't need the empty anymore, right? I don't think anybody's using this. Dylan, I don't know if you speak Spanish. Maybe you do, but at least for my Spanish, the way that the trappers, right? That's what we call them, traperos. They sing. It is just so obnoxious. It's just very, very like someone. I don't know how to say this. It's hard to translate. Uh, but like someone is, when some maybe I don't know, someone's gonna like teach you to fight, for example, and they just like sort of have a certain vibe that they have. Um, but I don't know how to say it in English, but we was like the direct translation would be that someone is like pushing you, but they're not really pushing you. They're just like trying to get you to fight them, that sort of thing. Uh, the word I would use in Spanish is like descansando, which means to rest, but it's a verb that you would use on somebody else, like someone is resting you, right? To say like somebody is, yeah. Hopefully that makes some sense. But that's how they talk, right? Like to me, like to my ears. And this is Rodrigo. This is very much party music. Like this is the stuff you go out to dance to, or used to, anyways. No, not really. We can put some of that music on. Like I've danced to Daddy Yankee, Don Omar, Wisin y Yandel, all of those, right? But not really my cup of tea for like sitting down. I'm going to listen to this music. This is called cuarteto. It's like a genre of Latin music. No, I've been living outside of Argentina for about 12 years now. Yeah, I left when I was 19, and yeah, right now I've been the last 8 years in Sweden. So I've also had to learn a little bit of Swedish. And we're double closing. That's good. That's better than not closing at all. All right. So we can probably just come here and just do that. Socorro es. You did. Nice. There's a big Brazilian diaspora here in Sweden. My friend that I'm cat sitting for, she's actually from Rio. Rio. What's the state that you're from? Paulista, Carioca, Gaúcho, Carioca. Nice. I like Minas Gerais. I think they have better food than Rio. That is not a very controversial opinion. What in the hell is happening here? Okay, okay. So how do you call someone that is from the state of Rio but doesn't live in the city? Gotcha. El acento fluminense. Tá. What in the damn hell is happening here? Okay, so at the risk of failing that, I think the problem is that we don't have a connection. This is a socket. This is a socket. We only have a connection here, right? After we go through the handshake, then that goes into here. But really, this call stack is going to be the one that eventually sort of does something good about it. So I think maybe here would make sense for us to try to close the socket, right? What are we listening to? Grupo Frontera and Bad Bunny. 1%. Oh, nice. Yeah, small time Sweden can be super beautiful. So funny. Okay, I think that small change hasn't broken anything yet. The performance seems to be okay, up and down, within like 3 and 400 megs. So we can now maybe say always close the connections, right? Fig feet always close connections when exiting the connector. We'll install this and we'll go back to Nomad. And this should rebuild. Perfect. Yeah, pretty much the same here. A little faster, I think. We have some more runs there, but not much more. So we can run Hoja and see what happens. Okay. We have only a few connections reset by peer. That probably means we are doing something wrong. Just don't know where. Let's see that. That's nicer, right? Like 11 milliseconds, right, per request. We have most of the requests in that range, 11 through 17. It would be good to get this to the point where we don't drop connections, there's no timeouts, right? Hmm. Connection closed before message completed. Let's Google that, because I don't know if there's something about the protocol that we're doing wrong, right? That we should fix for that to not happen. So connection closed before message was completed. So right now I am doing a little bit of consulting, and yeah, I'm doing OCaml professionally for sure. Doing some Erlang professionally as well. Connection closed before message completed. Ooh, yet another tool for benchmarking. Hey, written in Go. Okay, cool. Let's do that. Brew install Hey, because the last thing, you like Hey? Cool. I live Hey. But that's kind of the same problem we're having, right? Like we do Hey. What? Oh, we need to include the HTTP. Come on, this looks the same, exactly the same as Hoja.